It comes down again to your knowledge of the parent function and also the standard form. Right? So if I were to just make a note, I wrote it on the board, but I'll write it again, that the standard form is a times the cube root of x minus h plus k. That's if you're dealing with a cube root function. And y equals, kind of box myself in here. I'll put it above it, I guess. A times x minus h cubed plus k. So you can do all these on the calculator. It's really just a matter of finding convenient points in a table. You want to center it generally around 0, and then look for the convenient points. But what you're dealing with when you're looking at a cubic function specifically, let me shut off the cube root. Not to get too advanced here, but there is a change in the, I don't want to use the word concavity, but I guess I have to. Just the shape of the graph, it transitions from facing, kind of opening downward to opening upward, right? Where that transition point happens, it's called a point of inflection, but that's not important. But that transition point, that needs to be part of your graph, right? So in order to create a cubic function, you need that transition point and 2 other points, one on either side, right? So as long as you can get that from your table, you're in pretty good shape. But if you know the parent function, then everything else kind of falls into place. So the parent function has coordinates 0, 0, 1, 1, negative 1, negative 1, negative 2, negative 8. And positive 2, positive 8. All right, I'm not going to color that in with a smooth, or draw it in with a smooth curve, because that's not my final answer. All right, what I want to do is I want to shrink this down by a scale factor of 1/2. All right, so all of these y values are going to get chopped in half. And then we put the smooth curve through it. All right. But you're working off of that parent function. Right? So it's the same idea with the next one. I'm going to take all of my blue points and shift them up 4 units.
Where are we getting the blue points from?
Oh, the previous page.
Oh.
Yeah, because that's the parent function y equals x squared. I just grabbed them from the table. It's that graph. And in all honesty, I mean, it's one of those things like, do you really have to do it this way? No. But I can promise you that I was able, and there's no exaggeration here, it's not like I'm not looking at an answer key, I didn't memorize the answer, in fact I don't even remember doing this problem with the other class. I plotted those points before you would have been able to even type in your equation and go to the table to get the points to plot. Right, just by knowing what the parent function looked like. Now, those coordinates, the blue ones that I had here, that I happen to remember from the previous page. Okay, well, that's all well and good, the fact that I remember it, but you might look at that and say, well, I got to go to the calculator anyway to come up with those points. Well, do you really? I mean, if you're just looking at the parent function, y equals x squared, cubed, I mean, really, how hard is it to cube a few values? 0 cubed is 0, 1 cubed is 1, negative 1 cubed is negative 1, 2 cubed is 8, negative 2 cubed is negative 8. After that, you stop caring because it gets a little out of hand.
3 cubed is 27.
27, that's off the grid, so we would disregard it anyway. Right? So, same thing with the power of 2. Like, I don't need a calculator for that. Now, again, you have the calculator as a resource, but knowing these transformations help you to understand things like domain and range and things like that. Right? So it's definitely worth your time. Right? So try to consider how to come up with these by hand, but again, ultimately you want to get stuff right on the test, on the Regents, so you'll go to the calculator at least to check your work, but at least give it a shot using the transformations. Right? So, like the next one is a what? What's going on with this one?
All right, so
Scratch,
Oh, all right.
shift for the sharp. Nope, it's
Shift.
shift to 2.
Jackson,
To the right.
Stretch.
A shift of 2 to the right.
I said stretch first.
And number 4,
Stretch, I then said a lot of gibberish. I think I said.
what's going on with number 4?
It's a,
Try to help them out.
Reflection of the x-axis
down
and a shift down to 3. Exactly. All right. And so if you know your parent function points, you're good to go. All right.